There's a law in the universe we all just kind of accept. Nothing can go faster than the speed of light. But have you ever stopped to wonder why? Why that specific speed? Is it just some random rule? Well, we're about to find out that this cosmic speed limit isn't really a rule at all. It's something far deeper, something woven into the very fabric of space and time. Let's start with a really strange but totally true fact. Everything you're looking at right now is in the past. See, it takes time for light to travel from an object to your eyes. It's an incredibly tiny amount of time for things in the room with you, but it's not zero. The consequence is pretty profound. You are always, and I mean always, looking at a slightly delayed version of reality. You can never, ever see the present moment. So, just how fast are we talking? Well, here's the number. Almost 300 million meters per second. Now, on a human scale, that is just absurdly fast. A beam of light could zip around the entire Earth almost 8 times in the time it takes you to snap your fingers. To us, it feels instantaneous. But, and this is a big but, on a cosmic scale, light is actually kind of slow. We even have a unit for it, the light year. And this is so important to get right. A light year is a measure of distance, not time. It's the ultimate yardstick for a universe so vast that the idea of instant just doesn't exist. We are all, in a sense, refugees of the past, looking out at the cosmos on a massive time delay. Just look at this incredible photo of the Trifid Nebula. This isn't what the nebula looks like today. It's a snapshot from 5,200 years ago. That's how long it took for its light to finally reach us. What's it doing right now? We have no way of knowing. And this really gets to the heart of the mystery. Why this speed? Why this specific number? What makes it the absolute unbreakable speed limit of the universe? To even begin to get an answer, we've got to go back in time ourselves, back to when we first tried to put a number on this speed and discovered that light is a total rule breaker. Galileo gave it a shot first, with lanterns on distant hills. He basically concluded it was either infinitely fast or just way too fast for him to measure. But the first real clue came from an astronomer named Ole Romer. He was watching Jupiter's moon Io, and he noticed its eclipses were a little late when Earth was far from Jupiter and a little early when we were close. He realized the moon wasn't changing. The light was just taking longer to cross the extra distance. It was the first solid proof that light had a finite speed. Fast forward a couple of centuries, and this leads a young Albert Einstein to one of the most reality-bending ideas in the history of science. He just proposed it as a fact. The speed of light in a vacuum is absolute. It's the same for everyone, no matter how fast you're moving toward it or away from it. And this is where our everyday intuition just completely shatters. Okay, think about it like this. You're on a train, and it's moving at 100 kilometers an hour. You throw a ball forward at 20. To someone standing on the platform watching you go by, that ball is moving at 120 kilometers an hour, right? The speeds just add up. Simple. Yeah, but light doesn't play that game. If you're on that same train, even if it's moving at 99% of the speed of light, and you switch on a flashlight, the beam of light still moves away from you at the speed of light. And the person on the platform, they measure that same beam moving at the exact same speed. The speeds just don't add. Light speed is stubbornly, weirdly, constant. Now, for that bizarre fact to be true, something fundamental about reality has to give. And it turns out that something is the universe itself. So here's the mind-bending part. If the speed of light refuses to change, then something else has to. And that something else is space and time. As you start moving faster, time itself literally starts to slow down for you, and the space in your direction of motion actually contracts. Space-time is flexible. It will stretch and squeeze in whatever way is necessary to make sure everyone agrees on the speed of light. And this leads us right to the reason for the speed limit. The faster an object with mass moves, the more energy it takes to speed it up even more. It's like its resistance to acceleration increases. As you get closer and closer to the speed of light, this resistance approaches infinity. To actually reach the speed of light would take an infinite amount of energy. And since there's no infinite energy lying around, it's physically impossible. Game over. But hold on. That explanation, while it's totally correct, it kind of hides a deeper secret. All this time, we've been calling it the speed of light. What if the limit has nothing to do with light at all? I mean, it's the question we all have, right? What's so special about light particles, about photons? Why do they get to be the cosmic pace setters for the entire universe? So let's try flipping the question on its head. What if the constant that we call c is just a fundamental property of the universe, and light just happens to be the most famous thing that travels at that speed? Let's break this down into two simple facts. Fact 1. The universe has a top speed, a maximum velocity at which any effect can follow its cause. It's the speed of causality. We call this universal constant c. Fact 2. Any particle that has zero mass, like a photon of light, has no choice. It has to travel at this maximum speed. So you see, it's not really the speed of light. It's the speed of the universe, which light just happens to move at. And the proof has been hiding in plain sight this whole time, in the most famous equation ever written, E equals mc squared. Think about it. This equation isn't about things moving fast. It's a conversion rate between matter and energy. And yet, there it is, c. Its presence here shows us that this number is stitched into the fabric of reality itself, in a way that goes way beyond just how fast a photon can travel. Okay, so if c is a fundamental property of spacetime itself, where does it come from? For a potential answer, we have to shrink down, way down, into the quantum realm, and look at the truly bizarre nature of so-called empty space. We think of a vacuum as nothing, as total emptiness. But quantum physics tells us that's completely wrong. The vacuum is actually the lowest possible energy state of the universe, and it is a seething, roiling ocean of invisible quantum fields. Think of a perfectly calm ocean. It looks flat from a distance, but up close, there are always tiny ripples and waves. The quantum vacuum is like that. Its fields are constantly jittering, and these fluctuations create tiny pairs of virtual particles that pop into existence for an impossibly short moment before vanishing again. On average, space is empty, but moment to moment, it's a frantic hive of activity. And this leads us to a really fascinating cutting-edge theory. What if a photon, as it travels, isn't really moving through pure emptiness? What if it's constantly bumping into these virtual particles, getting absorbed and re-emitted over and over again? Each tiny interaction acts like a minuscule speed bump, creating a cumulative drag. From this perspective, the speed c isn't a property of light at all, but a property that emerges from its journey through the buzzing, empty vacuum of space. So let's take a step back and pull all of this together. Let's see where our journey has taken us and what questions are still lingering right at the edge of what we know. Okay, so why does light travel at c? Well, a leading idea is that it's because of its constant interaction with the quantum vacuum. Why is c the absolute limit? Because spacetime itself will bend and warp to keep it that way. But what is c, really? What is the deep, fundamental origin of this constant that dictates the entire structure of our reality? That is still one of the biggest unanswered questions in all of physics. And that leaves us with one last thought to ponder. The cosmic speed limit, a defining feature of our reality, might just emerge from the invisible, frantic buzzing of what we used to call nothing. And if that's true, if the very foundation of our universe is built on the vibrations of the void, what other fundamental truths are hiding all around us, just waiting to be seen?